we are going to continue our exploration into matrices, and we're going to look at inverses of a 2 by 2 matrix. So what we are given for this example is we are given the matrix 2, 1, 3, 0. And what we do need to find is the inverse matrix. So let's define what an inverse matrix is. So an inverse matrix is a matrix with some values W, X, Y, and Z such that the product of the two matrices of the original and inverse INVRSE is the identity matrix. And just to pull out what the identity matrix is, what we're looking at is the value 1, 0, 0, 1. In our case, because we're looking at a 2 by 2. All right. So in other words, and again, if you need to pause this video to write this down, go ahead and do so. But what we would be looking at for our matrix, again, we write this out because it went away, is something I will multiply to this to equal the identity matrix 1, 0, 0, 1. And we've seen these identity matrix before. We've seen this when we were looking at system of equations. I went through something like this when we were looking at system of equations. So now what I'm going to do here is I'm going to take this. I'm going to keep these variables W, X, Y, and Z, and I'm going to multiply these and use the multiplication to work through this. So the first thing I'm going to do is do the first top row here. So that's 2W plus Y, 1Y. And then the next one is going to be 3W plus 0Y. Then I'm going to do 2X plus 1Z. And then I'm going to do 3X plus 0Z. And this again is going to equal 1, 0, 0, 1. All right, and again, remember this is the multiplication of the two, not the addition of the two. So we do have to go through the multiplication methods. Okay, now what I'm going to do is I'm going to do 2W plus Y equals 1. I'm going to pull each of these out. 3W plus, we don't have to do 0Y. 3W equals 0. Then we're going to do 2X plus Z equals 0. And the last one is going to be 3X equals 1. All right, so now we have that all set up. What I'm going to do here is right away, I know that W has to equal 0 from this. And I also know here that X will equal 1/3. Okay. Now using this idea, I know that W is 0, which means Y, since W is 0, Y is going to be equal to 1. And X is 1/3. So 2 times 1/3, that's 2/3. So Z is going to equal -2/3. And all I'm doing here is just solving for each of the variables. Now I could rewrite this as a matrix. So my matrix here is W, X, Y, Z is going to be equal to 0, 1. Y is 1, X is 1/3, and Z is -2/3. All right, so there we go. We have all the pieces. Now I could say that the inverse matrix of the matrix 2, 1, 3, 0 is 0, 1/3, 1, and -2/3. And again, if I multiply these together, then we get that 1, 0, 0, 1 output. Okay, so let's see another matrix. Let's look at another one. Let's look at the matrix 1, -1, -1, 1. So what is the inverse matrix of this one? Well, again, let's start by multiplying this. 2, W, X, Y, and Z. And I know that this is going to equal 1, 0, 0, 1. Okay, multiplying this through, we have W minus Y for this first one, -1. So it's going to be -W plus Y. Next one's going to be -X plus Z. And then, actually no, so I went a little bit too far. This 1, XZ, so that's going to be X minus Z because of the negative, and then -X plus Z there. This is equal to 1, 0, 0, 1. Okay, now I'm going to set each term equal to its respective value. So W minus Y equals 1. Then I'm going to do -W plus Y equals 0. We have X minus Z equals 0. And then we will have -X plus Z equal to 1. Next we solve for our terms. We could combine things, we could divide things, but looking at this, well, here if I multiply by -1, then we get W minus Y equals 0, but we've already established that W minus Y equals 1, so it can't be both at once. There's nothing we can do here. Even if we did this here, we multiply by -1 on both sides. We get X minus Z equals -1. And again, we can't have 0 and 1 being a solution for these two variables. So looking at this, I will say the matrix, let me write this in a different color. So I'm just trying to look for a vibrant color that I want to use for this. The matrix -1, -1, -1, 1, does not have an inverse function. An inverse function. I'm going to underline does not have, because there are functions that, or there's some matrices that don't have inverse functions, inverse matrices. Oh, and I put an inverse function instead of matrix. Let me correct that. Make this erase a little bit bigger, because erasers are math's friends. So there we go. All right, so there are two examples of the inverse of a 2 by 2 matrix, one where we actually find the inverse and the second one where we don't. Again, guys, if you have any questions, always feel free to ask, and I'll catch you in the next video.